All right, so a couple things we want to look at in this video. We have the first one is how to take a logarithm and turn it into an exponential, or vice versa, going from an exponential to a logarithm. So the first one, we have this format that we can remember, or we just know what operations cancel each other out. So we know logs and exponentials from algebra are inverses. So they are inverse functions. So if we do the opposite to what's there, we will cancel it out. So let's say I have log base 2 of 8 equals x. So if I want to change this into an exponential, I need to get rid of the log. So we get rid of a log base 2 by doing a base 2 exponential. So a big 2 on both sides of the equation. So the log base 2 and the exponential base 2 cancel out, and we're left with an 8 on the left. And then we're left with 2 to the x on the right hand side. So that's how you take a log to an exponential. So if we have, let's see, e to the x equals, let's say 5. So e to the x equals 5. How do we change this to a logarithm? Well, we need to get rid of the exponential, the base of the exponential. So we're doing the opposite log. So base e, we need to do log base e, which is natural log. So if we take the natural log of both sides, I'm going to try to squeeze this in over here. Natural log, the natural log and e cancel out, and we are left with x equals natural log of 5. And that's it for transforming these into the inverse. All right. So now the next thing. So this is kind of the big idea for the video. So that what we just went over was review from algebra. This logarithmic differentiation. So I kind of mentioned it the other day in another video. So we need to be able to take the derivative of this. So if I asked you to take the derivative of this regularly, it's going to be kind of challenging because we have product rule, we have chain rule, we have quotient rule, power rule. We have all these rules in here, so it's going to take us some time. So we can use this idea of logarithmic differentiation to make this a lot easier problem. So we have to know the rules that, the log rules that were in the other video. So you want to look back at those, and if you need help with them, let me know. So the first thing we want to do is take the natural log of both sides of the equation. So natural log is, it's an operation, so we can do it to both sides. As long as we do it to both sides, then we're good. So if I have, I'm not going to write all this out again, and so I'm going to skip a step. So if I take natural log of this, we have a multiplication, we have a division, and we have a couple powers here. So we know that this x squared plus 1 is to the -1 power, right? So as I'm going through, I'm going to piece it out. Actually, I think I get rid of this natural log here. So for natural log, this x to the 3/4, we use our power rule of logs. So the 3/4 power will jump down to the front of the log. So we have 3/4 times the natural log of x. So that's this piece right here. Now we have multiplication. We're multiplying by this. So whenever we multiply, that's the same thing as adding another log. So I'm going to add this natural log. So we have that half power up there, which is going to jump down to the front. And we take natural log of x squared plus 1. Okay, now we're dividing, so that's the same thing as subtracting a log. So we have a power of 5, which is going to go down to the front. So 5 times the natural log of the inside here. So 3x plus 2. Okay, so we've just created a situation where the derivative is going to be much easier because we have multiple terms here, and we know how to take the derivative of natural log fairly easily. So if we take the derivative of both sides, so derivative of ln y is 1 over y times y prime. Take derivative of this term, so 3/4 ln x, we're going to get 3 over 4 times 1 over x. So we get 3 over 4x. Plus, take derivative of natural log, so that's the constant, just stays in the problem. So derivative of this natural log, this would go to the bottom of the equation. So we have a 2 times x squared plus 1 on the bottom. And then we multiply by the derivative of the inside, which is 2x. Those 2's are going to cancel out. Okay, so we didn't multiply by the derivative here because the derivative of x is just 1. And then subtract, we have 5. Yeah, let me go back. So we have that 5 on top, but if we take derivative of the natural log, this is going to drop to the bottom. And then we multiply it by derivative of the inside, which is 3. So 3 times the 5 that's already up here is 15. Okay. So we can, like I said, we can cancel that 2 out. But what we need to know, so I want y prime, right? We're trying to find derivative. So I need to get rid of this 1 over y. So I need to multiply both sides by y. And what is y? Well, it's the equation that they gave us at the beginning. So we're multiplying both sides by y. So I go y prime, 3 over 4x, we have x over x squared plus 1. Minus 15 over 3x plus 2. Okay, so all of this is being multiplied by y. So we're just writing the original equation again. So x to the 3/4 square root of x squared plus 1 all over 3x quantity to the 5th power. So, sorry, 3x plus 2 quantity to the 5th. And that is your answer. We're not going to really want to simplify this unless you want to, I guess. Have fun at it. But that's logarithmic differentiation. If you were to go back and try to do the derivative of this by your derivative rules without doing logarithmic differentiation, it's going to be a lot more work on this. So trust me when I say that this is an easier process and a quicker process. We just have to remember our log rules and know how to take derivative of natural log. So if you have any questions, please let me know, and I will see you guys later.